Our first example is probably the simplest version of a trig equation that we'll be solving. It's just going to follow linear methods. Now, if I graph sine theta, or 2 sine theta plus 1 in my calculator, it's not going to give me the equation of a line. But we're going to use linear methods, which means that I'm going to treat sine theta as my x. If I had 2x plus 1 equals 0 and I wanted to solve that for x, then I would subtract 1 from both sides and divide by 2 to get x by itself. So I'm going to do that same thing here, but when I subtract 1 from both sides, I'm going to get 2 sine theta equals negative 1, and then I'm going to divide both sides by 2, which gives me sine theta equals negative 1/2. So I'm ultimately trying to find theta, but I start out by solving for sine theta, getting it by itself, and then I have enough information to find the angle values where sine is equal to negative 1/2. So I need to use that inverse idea for sine and find the answers to this. My answers need to be between 0 and 360 degrees. There are an infinite number of angles for sine that have a value of negative 1/2. But we only want the ones that are between 0 and 360, because all of the other angles are going to be coterminal to the angles that we find in this first revolution of the circle. Okay, so we ask ourselves the inverse question: where is sine equal to negative 1/2? Let's deal with the negative first. I know that sine is negative in quadrant 3 and in quadrant 4, so my answers have to be down here. Now my next question, since 1/2 is a special value for sine, is what is a reference angle where sine is equal to 1/2? And you can use your hand trick for that, and you'll find that since we're in degree mode, our reference theta is 30 degrees. Now if we put 30 degrees as an answer, it's going to be wrong, because sine is positive 1/2 in this quadrant. But 30 degrees is also my reference angle right here. So if I add 180 plus this reference angle of 30, then I get an angle measure of 210, and that's one of my answers. I also have in quadrant 4 a reference angle of 30 degrees. So if I go all the way around the circle to 360 and back up that reference angle of 30 degrees, then this angle is 330 degrees. Now if I were to type sine inverse negative 1/2 into my calculator, then the calculator would give me an answer that's on this side bubble right here. So it would have told me that the answer was negative 30 degrees. But since our output has to be between 0 and 360, an answer of negative 30 degrees is not going to be correct. So from time to time, when these values are not special, we are going to have to use our calculator and use an inverse command. But we are also going to have to think about what we're trying to do. And we're solving an equation that has just trig in it to begin with, not trig inverse, even though we use the inverse idea later. So our two answers for this equation are that theta is equal to 210 degrees and 330 degrees. It's not necessary to check those answers, but I want to show you how to check them in the calculator. Now you may find that it's really easy to find the answers in the calculator, but keep in mind that on your final, you're going to have to show this work. If you just give calculator answers, then you're not going to get credit for them. So when we go to the calculator, we want to add a graphs page, and we're going to solve these by graphing. I want to make sure that my calculator is in the right mode, and if I hover over my settings, remember this is my document settings right now, and I'm in a graphing page. So I don't care about my document settings. I just want to make sure that my graph settings are in degrees. And you can see that the graphing angle here is in radians. So I need to change that to degrees because my answers in this problem are going to be in degrees. The document settings, well, it changed my document to degrees as well. The next thing that we need to check on is to make sure that we have the right view window. We don't want answers that are between negative 10 and 10. We want angles that are between 0 and 360. So I go to the window, settings, and X-min is going to be 0, and x max is going to be 360. That corresponds to the degree mode. Now I'm ready to enter the left side of my equation, which is 2 times sine x. Don't forget to arrow out of your parentheses for the angle, and then plus 1. Now I can see just that part of the graph from the first positive revolution of the circle, from 0 to 360. And you can see that there are two solutions there. There's a 0 right there, and there's another 0 right there. And if I were to menu, analyze graph, and actually find those zeros, then I would want to click on the left and the right side, and you see 210 for the x value, which is our angle. So that corresponds with the first one that we found. And then do the same thing again for the next one. Click on the left and click on the right, and 330 was the other degree measure for our solution. So that's an excellent way to check your work.